Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard, and this is Nikolai, founder of Postgres AI. Hey Nikolai, how's it going?
Hello, Michael. Going great. How are you?
Yeah, I'm good, thank you. So, what are we talking about this week?
Let's talk about why we can have writes on replicas.
Yeah, or the thing I've seen people get confused by is why they can get writes even on the primary for select queries, like
Right.
for read queries. But yeah, I like your framing.
Yeah, it can happen on primary as well. If
Yeah.
I mean, this surprise can happen on the primary as well. Yeah.
And specifically where people might notice this is seeing if they get buffers in query plans, like shared
Yeah.
dirtied.
Exactly.
But also, I think the place I've seen people spot it, at least when they mention it in blog posts, is PageStat statements or monitoring tools that are looking at PageStat statements and seeing that some of the top offending queries for buffers dirtied could even be select queries, and that really surprised them. So
Yeah.
it's kind of one of those surprising moments where you think, oh, is something badly wrong? And then you look into it and realize maybe not.
Yeah. Actually, to be fully clear, writes can happen during selects because of temporary files as well, right? And if you think about writes to disk, but this is pretty straightforward. We see it again in register statements. We can see it as well as temporary bytes or blocks written and read. And
Yeah, is it local or is it temp? I think it's local.
no, local is different. But I always forget what
No,
local
you're
is.
right.
Yeah.
You're right. Local is for temporary tables. That's why I get confused. Local is for temporary
Right.
tables and temporary
Right.
objects, but temp is for like if, for example, a sort or a hash spills to disk because it's too big for workmem or workmem times hashmem multiplier, then you get temp blocks read, temp blocks written. But I think what people are spotting is the dirtied and being like, wait, that should dirtied means an update or delete normally.
It's so confusing, right? I'm checking register
Yeah.
statements documentation, and for local blocks, head, read, dirty, written, and local block read time, write time, it only says total number of local blocks read by statement. Total number of local blocks, like everyone understands what local block is. Well, local block, okay, I think you're right. It's a block. I also saw, like, the more I deal with it in Postgres, almost how many years? Like 20 years, right? The more I dislike the fact that we call operations blocks. These are operations, not blocks. Because if we say 10 blocks written, it's actually 10 block writes. Maybe it's the same block which was written 10 times, right? Or
Yeah,
or
yeah,
read.
yeah.
So it should be block reads, block writes, block dirty. I don't know the proper word how to say dirtyings
Yeah.
or so, I don't know. But anyway, here, like, of course, I think it would be great to have understanding what local block is, right? Local block, I think it's, again, operation. Local block operation, it's what is caused when we work with temporary tables, which I
Yeah.
always try to avoid because of different reasons. Maybe we should talk one day about temporary tables. But temporary tables, temporary blocks is not about temporary tables, but rather about temporary files which can happen during execution of a query dealing with normal tables anytime because workmem is not enough, right? So again, this
Yeah.
is easy. This part is easy. If we see some select or update or anything is producing a lot of temporary blocks read or written, we need to just consider raising workmem or optimize query so it deals with smaller volumes of data, right? For example, I don't know, like just an increased selectivity of our, I don't know. It's a separate topic anyway. Let's
Well,
just
yeah.
point that writes can happen because of temporary files. Of course, selects can produce temporary files because workmem is not enough, and that's it, right? But then sometimes we have huge workmem, definitely, which is enough, and select is still writing to disk, or, well, technically dirty blocks dirtied. These operations, I will keep calling these operations, not data. These events, these operations can happen during selects, And if it's just dirty, it not necessarily goes to disk immediately, because this is the work for checkpointer and background writer, right? So, but it's already like, it's not good. Like select is producing some writes to the buffer pool, to share buffers area. And of course, if it's written, it's even worse, because I'm pretty sure this makes select also slow. Similarly, as it happens when it creates temporary file and writes to it, right?
Yeah, good point. Although I think in the two cases that we're going to be talking about, actually no, there could be a lot of them. I was thinking it's generally only, in a lot of the cases I've seen, it's only one block at a time. But actually, you could easily have a scan doing a lot of these. So yeah, could be a lot of data.
Yeah, and actually, to be even like absolutely precise, a block written not necessarily goes to disk, because this is written to a page cache, right? And then like pdflash or something like this is already about Linux. It should write to disk at some point. And this is like written doesn't necessarily mean that it goes to disk. And I think to understand that we should use different extension, because PGStar statements is great that it's available everywhere, because it's like, I think this is the most popular extension, should be at least among observers. And there is opinion that it should go to core at some point. It should stop being extension, especially after query ID propagated to PGStar activity to auto-explain, right? Definitely PGStar statements should be in core. But what I'm saying, there is PGStar Kcache, which extends PGStar statements to allow users see metrics related to actual physical resources, such as CPU, like user CPU, system CPU, and also disk I/O, real disk writes, real disk reads, how many bytes are written, how many bytes are read for each query ID, which is great. And I think, we talked that finally buffers are committed to explain analyze. By default, when you run explain analyze in Postgres 18, unless it's reverted, I hope it won't be reverted. In Postgres 18, explain analyze will always include buffers in the output, which is great victory. We talked about it a couple of years on this podcast, I think almost since the very beginning. And I was thinking what topic to choose next to complain about occasionally, regularly.
Or maybe campaign rather than complain.
Campaign, okay. Campaign.
More
Okay.
positive, yeah.
Right, so what kind of campaign to launch after this? Like, I was happy, but I was like, I will be missing us to talk about buffers and explain analyze and so on. So, and I chose the topic. I think we should focus on all managed Postgres platform builders and advertise to include PG weight sampling and pgstat-kcache to extensions. Because this is super important to have them both, to be able to do proper query analysis in different aspects. PGStar statements is great. It has a lot of metrics. It keeps growing in terms of number of metrics, but it doesn't have what pgstat-kcache and weight sampling provide. So we need those extensions on each serious database, especially heavily loaded, and pgstat-kcache is great here. And this would allow us to see, actually this query being select caused actual physical disk writes.
Yeah, I'm gonna have a think. If we only get one campaign, I'm not sure that's mine, but maybe. I like it. It's a good idea.
Okay, let's please consider this. I'm definitely launching campaign, at least on my Twitter and LinkedIn. And actually, I already launched it, and I saw a reaction from. So actually, I mentioned that these extensions are present on all serious setups, which we help to maintain for quite some time. And pgstat-kcache has been used like in serious databases I'm dealing with for a very long time, many years. And I know some platforms use it, but in different countries, right? And the only case I see is PG weight sampling is available on Google Cloud SQL. pgstat-kcache is not available there, but PG weight sampling is, which is great.
Are you sure?
I'm sure PG weight sampling is available, so you can have, like, imagine RDS. They have performance insights, which is great, but it's not. This information is not available through SQL interface. I'm not sure about CloudWatch. Maybe it's available there, like, but it's different API. I want to see details right in SQL because I have tools to analyze PG star statements, and I want extension to active session history analysis and also to physical metrics, which pgstat-kcache provides. So Cloud SQL has PG weight sampling, but it doesn't have pgstat-kcache. Others don't have any of these two. And reaction was from one of Cloud SQL engineers I saw, who promised to think about it. I mean, it would be great, and Cloud SQL could be much better if they have pgstat-kcache. I think they're already much better in terms of observability, better than RDS, because PG weight sampling is better than performance insights, and usually you combine multiple tools for observability, and you go for active session history for RDS or Aurora, you go to one place, to their own place. For everything else, you go to another place. It's not convenient. So in case of Google, they call it, I think, Query Insights or something like this. They have it exposed in their own monitoring interface, but they also expose it for anyone through SQL interface, which is great, right? Through PG weight sampling.
Mm-hmm.
If they have pgstat-kcache, I will be happy, but I also am going to ask others to consider these two extensions. For example, Crunchy Bridge, Supabase, who else? Everyone. I actually think RDS should consider PG weight sampling as well, and pgstat-kcache as well. Why not? So, yeah, it should be just an option. Users could decide. So back to our question. I think if you have pgstat-kcache, you can see actual writes happening from queries, and you can see selects, and you know work memory is enough, so it's not temporary files. You can confirm it through pgstat statements or also through individual query execution via explain analyze buffers. And that's it. You're thinking, what's happening, right? Why select is writing to disk? Or at least why is it writing to the buffer pool, which was already quite a surprise, right?
Yeah.
So,
and well, until recently, I knew this was a phenomenon, and I'd read about it a couple of times, seen it on the mailing list and in a post or two. But I only knew of one of the reasons, and the reason I think this came up recently is there was a good blog post by Alex Jessipal, I'm not sure how to pronounce that, sorry, who mentioned a second reason as well. So the first reason is related to setting of hint bits. Maybe we can go into detail on that one first, because that's the one I've seen most often and it comes up the most. Do you want to discuss that one first?
Yeah, let's do it.
So why do we have hint bits? And what are hint bits?
By the way, maybe it's Jesipov or Yesipov, but Alex is from Germany, I see, and works at Luminovo, which is interesting because we worked together last year. I mean, with his colleagues. It's interesting. I just realized it's
nice.
Cool. Yeah. I'm going to send him this episode for sure. So we have two cases, right? Two cases, and I'm not sure which one is the easiest. Let's start with the easiest, actually.
I think hint bits is easiest to understand, and it's most common. So my understanding of this is when new data is written to a page, at that moment, Postgres doesn't yet know if that could be part of a much larger, longer transaction, and we don't yet know if that transaction is going to commit or get aborted and rolled back. So we at that moment cannot say on the data page that this transaction has been committed and therefore should be visible to new reads of this page. So that information is in a separate log once the transaction does commit, and that means when you go if somebody's reading the page, they need to check which of these row versions has already been committed for sure. And if there's any ones where we don't know yet, but based on these hint bits, based on these 4 different flags, we can tell what status it is. Is it unknown? Is it definitely committed? Is it already out of date? Like, is it already been replaced? So if in the case of these reads causing writes, it's a subsequent read coming along, seeing a new row version that we don't know yet whether it's been committed, checking the commit log, and then setting, like, having read it once, it sets that and dirties the page, writes the page again to WoW, so that any future reads now don't have to check.
Right. Yeah. So yeah, hints can be like invisible, dead, frozen, right, for tuple. And the thing is that the most interesting part of it that this write can happen on a replica, which is kind of surprise for people, right? How come?
There's a really good. Oh, sorry. Just to go back to hint bits, there's a really good page on the Postgres wiki that describes it really succinctly, and there are 4 hint bits: xmin committed, xmin aborted, xmax committed, xmax aborted.
Yeah. So yeah, that's it actually. So we just know about this phenomenon and that's it. It should not be surprised that it happens. And subsequent
and it's healthy, right? It's not a sign of anything having gone wrong.
Right.
In healthy, like, it will happen quite often.
Yeah, and in case subsequent select already is not causing this, right? So it's because it's already updated, and it's kind of, you can consider it a kind of like dealing with warming up caches, but it's vice versa because it's writes. Right, so it's only this overhead is only present on the first very call with the same parameters. Of course, different parameters can cause such writes in different pages. Yeah.
Yeah, and it's necessary. It's a necessary result of us wanting to be able to serve things concurrently. Because of MVCC, we need versions of rows, and we need to then know which one should be visible to which transactions. So in order to do that, this is a necessary part of that.
Right. So yeah, let's talk about the second case.
Yeah, the second was more interesting to me. Like, I hadn't come across this before.
Yeah, let's talk about it.
So in Alex's post, I think you're probably right on the surname pronunciation, but I'm not going to try it again. He describes these as page pruning, he calls it, which I have not heard it called that before. And when I think of pruning, I think my mind naturally goes to, for example, the mechanism for removing an empty page at the end of a heap, for example. Is that also called pruning? But this is different.
I think it's truncation. If you talk about removing last page when vacuum does it, it's truncation.
That makes sense. So this is in almost like I think you before the call you mentioned it was described as a kind of in-page vacuum.
Yeah.
So it's like,
and it can happen during selects on the fly. Like it's interesting, right? Which is like also strange. But if we recall how hot updates are organized, which is great, a feature, unfortunately not available always because it requires two special conditions to be met. First is we are updating only we are changing values of the columns which are not indexed, and second is there is enough empty space in the same page where our old tuple is stored. In this case, so-called hot chains are created, and it can be multiple like versions in the same page of the same tuple. And in this case, what happens if we have index scan, we only know like the page and offset for the first. Indexes are not updated in this case because it's hot update. This is optimization to fight index write amplification, which is terrible Postgres MVCC behavior. Many projects are suffering from. When updating one row, having many indexes on the table, we need to update all of indexes, producing a lot of wall writes and like just making updates slow, heavy, and so on. In case of hot updates, if those two conditions I mentioned are met, Postgres writes only to the same page where tuple is already stored because there is enough space, and it doesn't update indexes at all because we are changing the value which is not indexed. And it produces a new version tuple, new row version inside the same page creating chain. It can be new. And when we have index scan, Postgres index scan points to the first version in the page, it's quick to jump between versions and find the actual one inside the same page, right?
One crucial thing that I think becomes important later is that chain information is stored in the header of the page, whereas the row, like the data from the row version, is stored at the end of the page.
Right. This is true. Yes, it's so. And if we already have old versions, at some point they need to be deleted. It can happen during vacuuming, or it can happen earlier if during dealing with this page, Postgres says, okay, we can clean up old versions right now. Why not? And it can happen during select as well, which is very strange.
Well, it's so cool, but I think again there's like a condition where it will only do this if there is not that much space left on the page. So I think the number is 10% of the page is left in terms of free space. There's some subtlety around if you've changed fill factor.
So which means that this is an effort to maintain hotness of updates further, because if without this we would need to go to another page, and this would definitely lead to updating all indexes, right?
Yes. But I think the optimization of not doing it unless the page is quite full means we don't have to do it that often. So for example, if we have maybe, let's say, a really quick 10, 15 updates of the same row and they all fit on the same page, and then we're having reads of that row in between, we're not cleaning up each version each time we do a read. We're waiting until we get full and then doing it in one go. So I think it's quite a pretty smart optimization.
It's a kind of trade-off, balance between like two worst situations and so on. So we don't do it too often, but also we try not to allow this tuple to drift to another page, which would cause the need to update indexes, because indexes point to the old page, right? So yeah, this is quite interesting. And again, this can happen during select. But it can happen only on the primary, right? Yes or no? It's my guess. I don't know honestly. Why? Because can it happen on replica?
Yeah, well, I don't know. Well, let us know in the comments if you know.
This is an interesting question, because if it's happening on replica, it means we have very different content of pages on both replica and primary, right? And like vacuum happening on replica, please no, because this changes the content of page, and I cannot understand how they page content should be synchronized in terms of tuples.
It's physical replica,
yeah. So it should happen only on the primary, because and the replica should just get this content. With hint bits is different. Hint bits, like it's additional information, and it doesn't change how tuples are stored inside the page. This thing is changing. It's cleaning up the space for new tuples. So it should happen only on the primary, I think.
That makes sense, yeah.
Okay.
Logically on a physical replica.
Right.
Yeah, okay.
Well, good.
There's one more open question. Yeah. I saw when this latest blog post was shared to Reddit, there was a really interesting comment that no one has replied to, and there's almost no activity on it. But somebody posed a question, I think it's a good one, whether there might be a third possible cause of this, and so it's more of a question to listeners, because I'm not actually sure. I don't know myself and haven't been able to confirm for sure. But there's a PD all visible flag on pages. And that might be a third way. If selects can flip that based on visibility of all the rows or the tuples in the page, then that might be a third case. But I don't know if selects can. So yeah, again, if you know, I'd be really interested to hear.
Yeah. So I guess that's it, right?
Yeah.
So yeah.
So yeah, great blog post. There's also an old one from Nikolai Sivko on the OK Meter blog that I'll share. So there's a few articles to read more about this.
Correction. Nikolai currently has a new startup which is called Corut.
Yes.
Yeah. So then Okimeter is his old startup, and Peter Zaitsev, from founder of Percona, joined Nikolai recently, not very long ago, and I'm like, Corut is a great project, but I guess this blog post was created while Nikolai was working on the previous project and just started observing writes happening from Selects and was very surprised and decided to blog about it. So
yeah. Well, it was a monitoring project as well, right?
Yeah. It had very good Postgres related features in it, which were, I guess, in some practices were inherited by Corut. And but Corut is amazing. I just a couple of words about it. If you like flame graphs, Corut can show you dynamically. Like, imagine you have a dashboard, you choose time for Postgres, and you see flame graphs, but like hanging down, so they are like 180 degrees rotated or mirrored, right? Horizontal mirror. And you can see details. What was like if you have debug symbols installed. I think everyone should have debug symbols always installed. You see deep details, what's happening, where time is spent, and dynamic diagnostics like this. It's crazy. I think probably I should add this to recommendations for Postgres platform builders, managed Postgres platform builders, because to consider Corut as also like good thing for observability.
It's open source, right?
It has open source. It has, I think it's like kind of open core model. I'm not sure, but the main thing is definitely open source. Again, I'm not sure.
Thanks so much, Nikolai. Thanks everyone for listening, and catch you next week.
Thank you, Michael. See you soon. Bye.